Chapter 6, Section 5, Data Visualization for Higher Dimensions. Sometimes we want to see relationship between three or more variables. That is, we sometimes want to implement multivariate analysis that includes three or more variables. So, how can we visualize the relationship between three or more variables? Human eyes can recognize up to three-dimensional space and cannot recognize four-dimensional space. So, we cannot visualize four dimensions at once. This is a limitation of data visualization. If we want to visualize a relationship between three variables, we can create a 3D plot like this. This is a 3D scatter plot consisting of three continuous variables. It looks stylish, but it is difficult for us to see the relationship between the variables. Our eyes are not good at obtaining insights from 3D plot. So, if we want to visualize three variables at once, an effective way is to use 2D plot to represent three-dimensional space. Here, let me show three types of plot: cluster bar plot, colored scatter plot, and bubble chart. We should choose the appropriate one depending on the pattern of variable combinations. If we visualize a numerical variable by two-fold categories, we can use a clustered bar plot. If we focus on a relationship between two numerical variables by category, we can use a colored scatter plot. If we want to see the relationship between two numerical variables, we can use a bubble chart. First, let's see what a clustered bar plot is. When we visualize a numerical variable by two categories, we can use a clustered bar plot. Suppose we want to visualize data shown by this cross-tabulation table. This table represents the average level of work motivation measured by multiple 7-point scales. The average values are computed by job categories and by age groups. In such a case, a clustered bar plot is useful. Its horizontal axis represents a category, here, job category. The vertical axis represents the value of the numerical variable, average motivation. And the bars of each category are further divided by another category, age group. In this way, we can visualize three-dimensional data, two categories and one numerical variable. When we want to visualize categorical difference in the relationship between two numerical variables, we can use a colored scatter plot. This is an example of a colored scatter plot that visualizes employee data. The x-axis is work motivation, and the y-axis is job performance. And three types of that color are assigned to each dot, depending on each employee's job category. It shows that, in general, work motivation positively relates to job performance. However, we can see many of the developers are both high in motivation and performance. On the other hand, many of the salespersons are both low in motivation and performance. So, this company may be excellent in product development, but lose many sales opportunities because of its weakness in sales force. Using a colored scatter plot, we can obtain insights that we cannot see in an ordinary scatter plot. When we want to visualize three numerical variable relationship, we can use a bubble chart. This scatter plot visualizes the relationship between work motivation and customer satisfaction. The data unit is a company's branch offices, so both work motivation and customer satisfaction are the average of each branch office. As we can see, the relationship is positive, suggesting that branch offices with highly motivated employees can achieve high levels of customer satisfaction. But here, we want to add another information, the sales amount of each branch office. In such a case, we can visualize the sales amount by the diameter of each dot. So, the dot size represents the volume of sales amount. A diameter is a continuous variable, so it is appropriate for representing a continuous variable such as sales amount. As we can see, in this company, large branch offices are low in both work motivation and customer satisfaction. These large branch offices may significantly drag down the company's overall performance. From a bubble chart, we can obtain insights that cannot be seen in an ordinary scatterplot. Let's summarize the points in this chapter. Data visualization is useful in data exploration because it reveals underlying patterns that cannot be recognized only by quantitative metrics. Data visualization is also powerful in presenting data because it provides audiences with intuitive understanding more easily than quantitative summary. There are various ways to visualize data, and we need to choose appropriate methods depending on our purpose, variable types, and types of variable combinations. Inappropriate visualization often results in confusing and misunderstanding presentation. And we should not be confused by such inappropriate visualization. Rather, we should be able to point out the problems and suggest better visualization methods. Thank you for watching. Please thumbs up and subscribe to my channel.